Hello students. Today we are going to start with session 2 of our lesson, the circle. Today we are going to talk about the relative positions of two circles. So let's check this application and discover the new rules. Now we are going to see, as we said, this application to discover the different relative positions between any two circles. I'm going to move this circle. So as you can see, we have different relative positions. It could be outside, this blue one. It could be inside. Similarly, this one. Okay, so we have five different relative positions. These two circles could be far away apart, externally disjoint. Look, if you put this one inside, they are internally disjoint. Disjoint means they are not touching each other's, no common points. If you want to say, teacher, they could touch each other. Yes, it's true. If they touch each other in one point, these two circles will be tangent, but internally from inside. These two circles could be also tangent externally from outside. Tangent means we have one common point. Okay? These two circles could be secant circles. What is the mean of secant? Secant means they are cutting each other's in 2 points. So we have two common points. So what are the five different relative positions of any two circles? Any two circles could be disjoint, externally, or internally. Any two circles could be tangent externally or tangent internally. And the final case, any two circles could be what? Secant circles. Now let's look on the numbers to the right. As you can see here, AE, this is the measure of radius AE, the radius of the orange circle. FO is the measure of this circle. Its radius is equal to 1.69. Okay, this is the radius of this circle. Now let's look on these numbers. This is the distance between the centers. Here it's center A, here it's center O. We already joined these two centers. The distance between this center and this center is 4.78. So what we are going to do? We are going to compare the radii of these circles with the distance between their centers. So, first of all, we are going to add these two radii and to subtract these two radii and compare them with the distance between the circles. If the two circles are tangent, look here, this radius plus this radius, the sum of the radii is 4.78, is equal exactly to the distance between these two centers. Why? Because these two circles are tangent externally. They touch each other by 1 point. But if we take this circle away, okay, does the addition of the first radius plus the second radius is equal to the distance between the two centers? Of course not, because here we have EF. Okay, so look here, if I add these two radii, AE plus FO, the answer will be 4.78, while the distance between the centers is 7.39. It's greater. So we conclude that if these two circles are externally disjoint, they are far away from each other. Okay, so the distance between the centers will be greater than the sum of the radii. Okay, if these two circles are tangent, the distance of between the centers will be equal to the sum of the radii, and so on. We are going to learn the different, in each case, the different position, relative position between two circles, and the relation between their radii and the distances between their centers. After checking the application, we notice that we have 5 different relative positions between two circles. So let's try to match these figures of the first row to the corresponding names from the second row. These circles could be intersecting, which means secant circles, internally tangent, or internally disjoint, or externally disjoint, or externally tangent. Please pause your video and try to solve this application. I guess these two circles, no common points, so they are disjoint, but internally from inside. These two circles have two common points, so they are intersecting or secant. These two circles, no common points, so they are disjoint but externally. These two circles have one common point, but from inside, so they are tangent but internally. And these two circles are externally tangent. So please check your answers. Now let's study their properties. We're going to relate the radii, as we said before, of the two circles to the distance between their centers. So starting with the first case, these two circles are tangent internally. They have one common point. Look at the first radius, it's 4. Look at the second radius, it's 2. First of all, we have to add these two radii and to subtract these two radii. Now look at the distance between the centers, center O and center A. It's equal to 2. What do you notice? We notice that 2 is equal here to 2. So OA, the distance between the centers, is equal to R minus R prime, or R1 minus R2. Okay, they are tangent internally. While in this case they are tangent externally from outside. Also one common point. This is radius 1, this is radius 2. Add the two radii, subtract the two radii. Then compare these two with the distance between the centers. This one will be given. Okay, it's given, it's equal to 6. So if we compare it, we note that AO is equal to the sum of the radii. So if we add OE plus EA, it will be equal to OA. Now look at the third case, internally disjoint. So they are inside each other's but without any common points. Similarly, radius 1, radius 2. Add these two radii, subtract these two radii, and look at this given distance. The distance between these centers is equal to 1.46. Is it equal to the sum? No. Is it equal to the difference? No. This one is less than the difference between the two radii. So AO is less than R1 minus R2. We say these two circles are internally disjoint. Case 4, externally disjoint circles. These two circles with no common points, they are outside each other's. This is radius 1, this is radius 2. Add the two radii, subtract the two radii. Then we have to compare these two numbers with the given distance between the centers. The given distance is 6.45. Is it equal to 6? No. Is it equal to 2? No. Then these two circles are not tangent. This one is greater than the sum of the radii. OA is greater than R1 plus R2. These two circles are externally disjoint. Finally, the intersecting circles or the secant circles. This is R1, this is R2. Let's add these two radii. Let's subtract these two radii and let's look at the given distance. So as you can see, I'm following the same steps. Let's compare. Is it equal to the sum? No. Is it equal to the difference? No. 4.45, is it greater than 6? No. Is it less than 2? Also no. 4.45 is in between 2 and 6. So OA is between R1 minus R2 and R1 plus R2. So whenever you subtract the radii and add the radii and you find that the distance between the centers is in between these two values, then these two circles are secant. Note that if two circles have the same center, we call them concentric circles. They are having the same center. So, as a summary for the 4 cases, pay attention. If these two circles are tangent, the distance is equal. If it is tangent internally, the distance is equal to R1 minus R2. If it is tangent, if they are tangent externally outside, the distance is equal to R1 plus R2. So tangent gives me equal. Internally gives me minus. Externally gives me plus. If these two circles are disjoint, pay attention, keep it in your mind, disjoint, no common points. They could be disjoint externally outside or they could be disjoint internally inside. So if they are disjoint internally inside, the distance is less than R1 minus R2. If they are disjoint externally, the distance between the two centers is greater than R1 plus R2. Okay, when we say internally, we put minus. When we say externally, we put plus. And the last case is the intersecting circles. The distance between the two centers is in between R1 minus R2 and R1 plus R2. So, which steps I'm following? To determine the relative position of two circles, please follow these steps. 1. Please calculate R1 minus R2. And you have to make sure that you put the greater radius first. Step 2. Please add these two radii. So first we calculate R1 minus R2 and we calculate R1 plus R2. Step 3. Here we have to compare. To compare what? The distance between the two centers with the difference and the addition. And you got the rules. So finally, let's repeat. If the distance is equal to R1 minus R2, these two circles are internally tangent. Internally tangent. If the distance is equal to R1 plus R2, these two circles are externally, we have plus, and they are tangent. If the distance is less than r1 minus r2, these two circles are internally disjoint. If the distance is greater than r1 plus r2, these two circles are externally disjoint. And finally, if the distance is in between r1 minus r2 and r1 plus r2, these two circles will be intersecting circles or secant circles. Please review again these rules and try to understand them well. By this, we end session 2 of our lesson. Goodbye.